Hello friends, so today class we will discuss about the circular motion. So what is the circular motion? So by the name only we can say that any motion that is happening on a circular path, then we say the motion is what? Circular motion. So there are two types of circular motion. One is uniform circular motion, and another one is non-uniform circular motion. Non-uniform circular motion. So in uniform circular motion means when the speed of the object while movement of the circular path, the speed of the object remains constant. It means the direction will definitely change because this is what circular motion. So direction will keep changing. Here we can't say that direction will what remains constant. Why? Because at every point its direction will change. But what can we make a constant? Speed means magnitude of the movement. For example, if it is moving with v meter per second, so everywhere its magnitude will be remain same. It will be v meter per second. Okay. So here we can say that in a uniform circular motion, speed of the object remains constant, not velocity. Speed remains constant. Speed remains constant. Always keep it in mind, in a circular motion, velocity can never be constant because velocity includes magnitude as well as direction. So here magnitude can be constant, but direction will always change in a circular motion. So velocity can never be zero. So we will say uniform circular motion of any object is said to be a motion in which when object moves on a circular path, its speed remains constant. Correct? So now next one is non-uniform circular motion. So non-uniform circular motion means when object moves in a circular path, so either its speed will change or direction is definitely changing. Speed will change. Then we say what? It's a non-uniform circular motion. So when speed changes. So direction is keep changing. Direction will change in both the cases. Either it is uniform circular motion or non-uniform circular motion. But in uniform circular motion, speed remains constant, and in non-uniform circular motion, speed also changes with the direction. So now, in the next we will discuss about the standard properties of angular motion. So why I am saying that angular motion? Because whenever objects moves in a circle, its angular position is changing. For example, the object is at initial point 1. After some time, its position let becomes 2. So what happens from point 1 to point 2? Its angular position get changed. Its angular position get changed. So here we have to define the terms. Those things, those are related with angular motion. So here we will define like angular displacement. Angular displacement. Displacement. Okay, so it is denoted by theta. Angular displacement, like displacement, we studied what the distance between what initial and final position. Same way here, angular displacement is what angular position. This is nothing but the angular position difference between point 1 and point 2. That is denoted by theta. That is what angular displacement, and it is denoted by theta, and its unit is radian. Unit is what? Radian. Correct. Next one is angular speed. Angular speed. Angular speed. We studied about the speed. Speed is what? Rate of change of distance. Here angular speed you say or angular velocity you say. Same thing. Angular velocity. Angular velocity. So here we can say that rate of change of angular displacement is called what? Angular velocity. Rate of change of angular displacement. Rate of change of angular displacement. Angular displacement is called what? Angular velocity. Correct. So its unit will be radian per second. Here we define angular velocity in two types. Angular velocity in two types we will define. One is average angular velocity. Average angular velocity. And the second one will be instantaneous angular velocity. Instantaneous angular velocity. instantaneous angular velocity. Now here, question arises, what is the average angular velocity? So average means what? The basic meaning of average means what? Final minus initial divided by total time. So here same way we will write here. The angular average velocity is what? Delta theta divided by delta t. Delta t. This is what average velocity. Angular average velocity. Same way instantaneous angular velocity, omega instantaneous is what? D theta by dt. D theta by dt. This is what instantaneous angular velocity, and this is what average angular velocity. The both unit is what? Radian per second. So see here, if you are keeping these things as a new things in your mind, it will be little bit difficult. So I will suggest that already you know that average speed and instantaneous speed, there you have studied that delta s by delta t and ds by dt. So same way here, angular velocity is what? Delta theta by delta t, and instantaneous angular velocity is what? D theta by dt. Why? Because here the displacement is theta, angular displacement is theta. There it was in a linear motion, it was s. So there we have taken delta s by delta t and ds by dt. Now next one is angular acceleration. Angular acceleration. Angular acceleration. So we say angular acceleration denoted by alpha. There it was the acceleration, and how we define the acceleration? Rate of change of velocity. Same way here, angular acceleration we will write it as a omega final minus omega initial divided by delta t. This is what average angular acceleration. Instantaneous angular acceleration we can also write it as a instantaneous angular acceleration. Angular acceleration alpha is d omega by dt. It can be written as d omega by dt as well as change in angular velocity divided by change in time. The unit is radian per second square. So these are the parameters that we have defined here. Like in a linear cases, we have defined the speed, distance, displacement, velocity, acceleration. Here we define these all the terms. I think so all of you understood this. Now, here the relation in angular and linear velocity. Angular and linear velocity. So linear velocity is what? For example, if any object is moving, so at every instant its linear speed is there. Let v, here also v, here also v. Let us consider it is constant, it's a uniform circular motion. So with the angular speed means omega, how can we relate it? So the relation, how can we do? So here you know that, for example, any part of it, if I will consider, let this part I am considering here. In that, a small displacement is happening d theta. So that part I will cut and I will observe here. Let in dt time, here the linear displacement is happening, small displacement denoted by ds. And the radius of this circular path is r. So we can write this is the r, and the small displacement is d theta. Correct? A small angular displacement is d theta. So here this is a very small part. This is almost considered as a small right angle triangle. Correct? So in this we can say that tan theta is what? Opposite by adjacent. So we can write tan theta is opposite is the ds by r. Because it is almost very small part, so we can consider it is what? Making 90 degree here. Correct? So here as a theta is very small. So theta we can write, tan theta equals to, we can write here, it is nearly theta. So we can write tan theta equals to theta, and theta value is d theta, small value. So we can write it as a d theta. This one we can write d theta. Okay now? Tan theta equals to theta, that means theta only we are writing, but that theta is very small, that's we are writing d theta. That's why I have represented here theta as a d theta equals to ds by r. So here we can write ds equals to cross multiply ds equals to r d theta. This is a relation between what? Linear displacement, radius, and the angular displacement. Now, this term I am writing again here, ds equals to r d theta, and then differentiate with respect to time. Differentiate with respect to time. So when we are differentiating, what we are getting here, ds by dt equals to r d theta by dt. So finally, ds by dt is what? Speed, speed, linear speed, and linear velocity, and then r, and d theta by dt is what? Angular velocity, omega. So v equals to r omega. This is the what relation between angular velocity and linear velocity. V equals to r omega, or omega equals to, we can write v by r. This is the relation between what? Angular velocity and linear velocity. I think so all of you understood this. Now next one is angular acceleration. So as we have discussed that v equals to what? R omega. Correct now? Correct. So here we can differentiate again. Differentiate with respect to time again. With respect to time. So it will be dv by dt equals to what? R d omega by dt. So finally we can write it is what? dv by dt is your, as the speed. If speed is changing tangentially, this is what? V. For example, this is v. Linear speed. It is not linear speed. With this, we have now just rate omega. So now if linear speed is constant, dv by dt is 0. But if v is changing, it means what? Tangent. In the direction of tangent, speed is changing, means tangential acceleration will be introduced. So here is what? Tangential acceleration, at. At equals to what? R into rate of change of angular velocity is what? Angular acceleration. Rate of change of angular velocity is what? Angular acceleration. So alpha is what? D omega by dt. Correct? And its unit already I discussed with you, radian per second square. So this is what? At equals to R alpha. At equals to what? R alpha. So this is what relation between tangential acceleration, and alpha is your angular acceleration. Angular acceleration. Correct. So this is the tangential acceleration, and alpha is what? Angular acceleration. The relation between them is what? At equals to r alpha. R is what? Radius of the circle in which the object is moving. R is what? Radius of the circle in which object is moving. The radius of a circular path. Circular path. Correct. Now, motion equations for a constant angular acceleration. We studied about the motion equation for a constant linear acceleration, like v equals to u plus at, v square minus u square equals to 2as, s equals to ut plus half at square. Same way here for angular acceleration is constant, means alpha is constant. If alpha is constant, we can write like we have written in linear motion. By comparing that, it is easier to understand. V square minus u square equals to 2as. This is for what? When a was constant. A was linear acceleration was constant. Correct now? So here same way, if alpha is constant, we can write what? Theta final square. Sorry. Here we can write omega final square minus omega initial square equals to, in place of a we can write alpha, so 2 alpha theta. Same way we can write v equals to u plus at. So here we can write v was the final velocity, u was the initial velocity, a is what? Linear acceleration. Same way final angular velocity is what? Omega f equals to omega initial plus alpha t. Same way here s equals to ut plus half at square. Here we can write theta equals to omega initial into t plus half alpha t square. So these are the important relations. We can just memorize by keeping this in mind. So this is what motion equation for constant angular acceleration. Here keep in mind that omega initial is what? Initial angular velocity. Initial angular velocity. Omega final is final angular velocity. Final angular velocity. Here alpha is angular acceleration, that is constant angular acceleration, and theta is your angular displacement. Theta is your angular displacement. I hope all of you understood. By comparing with the motion equation for a straight line, it is easier to understand this. Now we will solve some questions based on this topic. So here it is mentioned here some questions. We'll do one by one. Here it is mentioned that a solid body rotates about a stationary axis with an angular retardation alpha equals to k root omega. So it's given alpha value is as a k root omega, correct? Where omega is what? Angular velocity of the body. Find the time after which the body comes to rest. If at t equals to 0, angular velocity was omega naught. So at t equals to 0 means initially, omega initial was omega naught. So this type of question, when it was in straight line case also, we were using what? Differentiation integration, because the limits are given. So here, how to identify? We have to do differentiation integration. See here limits are given. You see the t equals to 0, it is mentioned. So t equals to 0, it is given initial value. That means we have to think about the differentiation and integration, because sometimes the students confusion is that how to think that we have to do differentiation integration only. So by these terms we have to understand that here some values are given, that is t equals to 0, what values are there. It means it's asking that other at what time, it is asking that final value. It means it is possible by what? Differentiation integration method only. So how to convert in differentiation integration? We know that alpha equals to, because here omega given, so alpha, we know alpha equals to, in terms of omega, it is d omega by dt. So we'll write it is as a d omega by dt alpha, and then it is k root omega. And we know that we have to find a time. So time one side we have to bring, and omega one side, then only we can integrate and we can find a time. Okay, so we will put here d omega by root omega equals to k dt. Correct. Now it is in integral form, so we can integrate it. So both sides we will do the integration. Here time is changing from 0 to t, and omega initial value is omega naught. Angular velocity of the body was omega naught. And in the question it's mentioned solid body rotates about a stationary axis with angular velocity. Omega is angular velocity of the body. Okay, now find the time after which body will come to rest. It means omega final is 0. It is given. Omega final is 0. Whenever it will come to rest, it will stop, means its angular velocity will definitely 0. It means finally it will be 0. That's why its limit is from omega naught to 0. Now you should sound in what? Doing integration. So what is the formula for integration? X to power n dx. It is what? X to power n plus 1 divided by n plus 1. Correct? This one we will do. Okay, so here we will use the same formula. So here we will write integration of, it is root omega will go up, it is omega minus 1 by 2 d omega. Now here it is omega naught to 0, omega naught to 0. Now what happened? Here it is what? K dt integration is t 0 to t. Correct. Now here we can write omega minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. Correct. And then omega naught to 0 we are doing. Now k t minus 0, we are putting the limits here. Now it will be what? It will be written as minus 1 by 2 plus 1 by 2. 2 will go up, then 2, and then it is a omega power 1 by 2. Okay, omega naught and then 0. That is what? K into t. So here just 1 by 2, 2 will come up, it will be 2, and then minus 1 by 2 plus 1 is omega 1 by 2, and you know power 1 by 2 means root. So we can write in the next step it as a 2 root omega 0 and omega naught equals to kt. So finally we will get here 2, 0 value will put here is 0 minus root omega naught equals to k into t. Correct. So finally, we will get the magnitude t value, it has a what? It is a 2, and here we will write it as a uh, minus 2 root omega naught by k. So time is never negative, so its magnitude we will take. It is what? 2 root omega naught by k. So this is your answer for finding the time. Because in the question, what is asking? You have to find the time after which the body will come to rest. So we have done that one only here. We have finded omega minus 1 by 2, and then minus 1 by 2 minus 1 by 2 plus 1. It is what? 1 by 2 only. So root omega only. Correct only, and the 1 by 2 2 it was. Then we will put the upper limit, that is what? 0. Correct. And then root omega. Correct. So we got 2 root omega naught by k. So this is what a time after which it will come in the rest. Now next one is a wheel is subjected to uniform angular acceleration about its axis. Initially its angular velocity is 0. In first 2 seconds, it rotates through an angle theta 1. In the next 2 seconds, it rotates through an angle theta 2, the ratio of theta 2 by theta 1. So see here it is given initially angular velocity is 0. So first of all, whatever data it is given, that we have to write. Initial angular velocity means omega initial is 0. Omega initial, it's given what? Omega initial equals to 0 radian per second. Now what is given? That in first 2 seconds, right? So t equals to 2 seconds. In t equals to 2 seconds, it rotates to an angle theta 1. So we will write that omega, it was theta, we have to find theta 1, and time it is given first 2 seconds. Then theta equals to what? We will write formula we have. Theta equals to omega initial into t plus half alpha t square. And as it is uniform angular acceleration, so we will write it is what? 1 by 2 alpha. Alpha is constant. We don't know the value. So we'll write it is a constant, certain value it is there. So we will put the value 0 plus half alpha t square. T value is 2. So 1 by 2 into alpha into 2 square. So here it will be what? 2 alpha. Theta 1 equals to 2 alpha. Now it is going next 2 seconds. Means initial 2 and then next 2. It will be total time will become what? T total is what? 2 plus 2 is what? 4 seconds. When total 4 seconds, then theta net is what? Theta 1 was initial. Theta 1 initial angular displacement plus in next 2, let it is a, it is given that rotates to theta 2. So it theta 1 plus theta 2. Total theta is what? Theta 1 plus theta 2. Correct. So here it is asking the ratio of theta 2 by theta 1. So again we will relate theta net equals to, we can write theta net equals to omega initial into t plus half alpha. Alpha value, it is what given? It is not given. We have to take constant only. So constant into t. Total time initial 2, then again 2 means 4. Now time is 4. So 4 square. Now it is what? Theta 1 plus theta 2. Theta net theta 1 plus theta 2. It is 0 plus 1 by 2 into alpha into 16. That is what? 8 alpha. 8 alpha. So 8 alpha. Theta 1 already we know. 2 alpha, that means theta 2 is what? 8 alpha minus 2 alpha. It is what? 6 alpha. It will be 6 alpha. So theta 2 is 6 alpha, theta 1 is 2 alpha. We have to find what? Theta 2 by theta 1. So finally we will get the answer. It is theta 2 by theta 1. It is what? 6 alpha divided by 2 alpha. Alpha cancel. It is 3. So answer will be 3. This is your answer. Correct? I hope all of you understood this. Now next question is the length of the second hand in a watch is 1 centimeter. The change in velocity in the tip is 15 seconds.